Hi, welcome to Foundations Enterprise DevOps Translate and Port Code. My name is Dennis. Let's go ahead and get started. Our learning objectives today include making decisions on selecting different programming languages for modularity and being able to analyze code in non Python languages. We want to go ahead and convert that function code from other languages to Python 3, in other words, porting. Now, refactoring means changing structure, but not changing function. So basically, that means porting code or even optimizing your own code within the same language. Let's look at some examples. So remember, refactoring, the main point is you want to optimize, maintain the same functionality, but the appearance may change, including different coding languages or decoupling. As long as your functionality is the same and you're completely optimized, that is the point of refactoring. For instance, what you see here is Visual Studio Code's recommendation to extract a new method. What we have here is a for loop, and then we could have a calculation of a sphere right here because it could be reusable code. Right? That is a portion of refactoring. Another example might be to move from a ancient legacy system such as a COBOL mainframe to decoupling into microservices. What you see in this item right here is the COBOL mainframe architecture, which is common in many different older legacy enterprises. Moving into the AWS Cloud, migrating, and completely refactoring. Now, refactoring costs a lot of money up front in terms of time and resourcing. However, if you invest in it, it scales reasonably and allows you to be forward thinking in terms of having modularity and additionally having the ability to reuse code elsewhere for future applications and needs and enhancements across a lot of different teams and development. Here you see scalability and less load balancing and going full serverless along with the app mesh of using Kubernetes man services, basically containers. Consider the business return on investment, including return on investment, rate of return, and whether you want to do self-hosting, cloud, or even hybrid options will help you determine if you need a refactor. Systems, services, and coding are all considerations. Remember that the level of abstraction that you're looking for also commits the amount of time and resources it takes to go from a monolithic and even legacy architectures to a brand new one that has scalability in the future. Is an application worth it to refactor if you're not going to plan to use it after 1 year? Is an application worth it if it's mission critical to your business, providing business value, and any downtime could result in profit loss? Those are things to keep in mind and help you really communicate as a developer with the business needs and stakeholders. Now, traditionally, you've gone from N tier, which usually has a three-tier architecture. Back in my day, when you split from one server to multiple servers, that was considered pretty advanced. Now, today, the presentation and logic and data tiers, all N tier, could be completely in the cloud using infrastructure such as EC2 or going full serverless. The choice is yours, but ultimately, you want to have distributed items, you want modularity, and to do so requires decoupling and desyncing. Some key points to include here. There's always a presentation tier, which is your client. The logic tier, which handles all the requests and starts creating events and pushing data to and from, processing data as well. And of course, you have your data tier, which is really where your data is stored. S3 as a bucket, uh, DynamoDB as a database, SQL databases. The choice is really yours. You also want to think about self-hosting, cloud, and hybrid options again, and really what programming languages work best at different layers of your tier. Now you got to think that Python was considered a great backend language. So you could have Python right here. But does it make sense to have in your presentation tier something else, perhaps Node.js? Now the reason why we might have different languages is because maybe different package supports. Uh, libraries are one, right? You could have a long-term support, which is, for instance, Python 2.0 was really terrible in terms of the support if you're trying to use it when it's already deprecated, right? You also want to think about performance. So maybe Python might be usable right here, but maybe you want to have C++ instead, right? All these could be useful for you, and you have to really decide as a developer what is best for your stack. Now, to help you with that is a language selection matrix. Right? These are things that are based on general industry consensus, community standards, and the amount of public support around them. In terms of development, right, you might want to think about your JavaScript, Elm, TypeScript, Scalas. That's front web, right? Your presentation tier. For backend as well, you might want to think about Python and many other ones, such as Go and Ruby, or right here. Mobile apps and development, right? And we might have Swift and Objective-C, which Objective-C is part of your iPhones. For gaming and development, you have Unity, which is a highly popular game engine, which also includes the ability with .NET in the back end. Desktop applications and general portability, well, Python is also great to go here. And as well as systems programming, well, in the modern languages, you have Go and Rust, but you also have the C family as well. So your language selection depends on experience, but also think about the support from a library and community standpoint. Matrices like these might help you. Again, depending on your use cases and how comfortable you are when picking up new languages. Ultimately, you still have to deliver. So let's take, for instance, something interesting here. Let's say you got a developer, you're a developer, you know Python. You know Python really well. You know you can get this knocked out within the sprints. However, to gain a 5% increase in possible performance using JavaScript for your front end instead of Python, but it might take you an extra 2 sprints to learn and get proficient at it. What's the cost benefit trade off here? Well, you might still go with Python and just choose to have optimizations outside of your code. So, different libraries, decoupling techniques, and scalability could help you achieve that 5% extra performance rather than having to try to figure out how to refactor yourself into JavaScript. Things to consider as a developer. All right, so let's look at some examples of porting to Python from different coding languages. C++ is a common example, compiled. What we have here, think about this. Pause the video and think about what you need to figure out here. Now, it's not that incredibly difficult, but I want you to get into the habit of understanding every aspect of the code and how to actually port it into the Python equivalent. I'll wait. All right. So obviously you can see here that we're using a hello world. We have to include our own library, and it's inside an encapsulated main statement, which we don't need to do in Python. So what we still have here is a standard out hello world, and that's it. Well, in Python, we know this. It's just print. Oh, print. Hello world. And that's all it is, right? That's what we do here. We don't need to do anything else and overcomplicate it. Cool. Port number 1 done. I hope so. What about C++ in example number 2? Let's add 2 integers together. Well, we want this output. And we want to say 4 and 5. And then it's going to say 4 plus 5 equals 9. That's what we want for the output. And here's how it gets it done. And notice the syntaxes here are quite interesting of using redirects inward with the carets. Take some time to look at this. This is a little bit more complicated now. Understand different aspects. I'll wait. Okay. Now some explicit points is that the main function is used. And we also have a variable explicitly typecast language, right? Everything that as a variable must be created in a specific cast of a data type. Here's our Python port equivalent. Now we have 2 solutions. So let's look at the first one at the top first. Well, to accomplish something similar, right? We can say 4 space 5 is 9, and use 1 line of input instead, which is really quite simple. Now we do modify the function a little bit, but for the most part, this makes it nice and easy for us. How about how we make it exactly? Well, we have to enter 4, enter, and then 5. Well, to do so, we have to ask the input twice, and then provide the actual input concatenated accordingly. Not too bad. That's our port for 2 different solutions. So if you want the exact replication, that's right here. That's a true port. And if you have a port in Tinker, well, you have a revision, which makes it a little bit better. Let's continue forward. How about a Node.js example? Well, we have a for loop right here, and we're going to print this out in a series of iterations 5 times. Notice that the syntax difference is a little bit different. Stop and think about what the video is and what the syntaxes look like, what they mean to you from a Python perspective. Okay, now that we're back, let's look at our for loop. We're starting with 0, less than 5. We have the counter incrementing 1 at a time, and then we want to say, hey, this is the step that we're on. Okay, this is our output. Let's figure out the Pythonic way of getting that output. We have 2 solutions again to do so. Again, remember, there's plenty of ways to do anything inside multiple programming languages and in the same language itself. Depends on your coding style. We start with a counter, and unlike Node.js, we just have to have the counter on the outside, and we have the count up condition with the while loop, or because we know we're going to use the exact range, we can use a range. Remember, we use 5, so we get a -1. So we have 0 through 4 at this case, and then we iterate over that range instead. Both achieve the same outcome, but solution 1 probably has the better flexibility in case that number needs to change in the near future. How about a second Node.js example? We want to create an API that says hello world when you come to it. They use the express syntaxing going on here. We're listening on port 8000. And any gets gives me back a hello world mock API response. And of course, here's my console. Here's my output. Again, port 8000, get REST API on the root. Doesn't sound too hard. Let's think about it from a Python perspective. Here's our Python equivalent. We use Flask instead of Express. Again, listening on port 8000, and we return using the defined function using the route of slash. Again, not too hard. You got to think about what available tools are there for you and continuously think about them. If you didn't understand what you were seeing earlier, go back to this slide, pause the video, and then once you understand what's going on, look at the Python port equivalent. All right, let's move forward. Ruby example 1. So Ruby is also an interpretative language. It was actually in competition with Python for a little bit. Still quite popular. Rapid7 uses it for its backend infrastructure for vulnerability scanning, which is kind of cool. All right, so we have some items here. Pause the video if you need to, but here we go. X equals 1. Write it to the screen. LF that's equals to 100. Write that to the screen. All else differs. Different value. Cool. Now, Ruby was cool for a Rails framework, which was made for web, or other ones got popular, like Python's Django. So let's figure out what else is going on here. How can we make the same thing with Python? Should be quite simple. Same X equals LF instead, and then finally an else. Okay, let's try something a little bit different. How about an example 2? Well, we have a puts I, we have a similar list format, and we have a for loop interval, but now we require a do at the end as well. And then we need to have an end statement here as part of our syntax. Should be simple enough for Ruby and Python to be ported. We actually have one less. Same listing style, for loop iteration, and just print. No need to end or do a do statement because of the indentation. All right, let's take a break. When we come back, you'll have a nice challenging lab to go ahead and wet your whistle with. We'll see you in the next lecture. Thanks for watching.